Next we want to show f is closed. To show that f is closed, the definition of a closed function is that we need to prove that for all closed subsets like H, capital H in X, in a domain, f of H goes to a codomain in Y, and to show that the f of H in Y is also a closed set. If we have any closed set like H in a domain, we need to show that f of H in Y is also a closed set. So for that, we first say that let H be any closed set in a codomain. Let H, and you know that every closed set in a usual topological space is a closed interval. So let H equals to a closed interval like A, B, be any closed subsets in X, means in R, in a domain. And what we need to show that f of H is closed in Y, which is also R. We need to show that f of H is closed in a codomain. So for this one, also we have three cases. Like first part, we show that the continuity for this one also we have three cases. So we have three cases. The first one, case number 1. If A 0 less than or equal to A, which is less than to B, for this part we find an f of H. So f of H equals to f of X belongs to R, but this R means codomain. So equals to all f of X belongs to R in a codomain such that X belongs to H, means we need to find all f of X for all X belongs to H, which is equal to all f of X belongs to R such that X belongs to H, means X belongs to A and B. And then implies that f of X belongs to R such that, you know, that this gives us this equation or this inequality, A less than or equal to X, which is less than or equal to B. And then you know that we want to find an f of X, and f of X is defined by X squared. So we need two squares of these parts, but in the first we say that A and B greater to 0, so we have no any problem, and we have not changed the inequalities, just we squared all sides, so equals to f of X belongs to R such that I squared less than or equal to X squared, and which is less than or equal to B squared, which is gives us equals to all f of X belongs to R such that, you know that X squared is an f of X, so f of X belongs to I squared and B squared, so it gives us I squared and B squared. So for all closed subsets H equal to AB, where A and B greater than 0, f of H is equal to I squared to B squared. This one is also an open closed interval, and all closed intervals are closed sets, so it is closed sets. So So for those parts, we give the solution. And the next one, second case number 2. If we say A less than to 0, which is less than to B, for this one also we need find f of h. F of h equal to all f of x belongs to R, means codomain, such that x belongs to A and B, which gives us f of x belongs to R such that A less than or equal to x, which is less than or equal to B, but you know that A less than 0, so this part gives divided into other parts, like that, equals to f of x belongs to R such that A less than or equal to x, which is less than to 0, means like that. This one 0, this one is A, and that one is B. So for x, where you say that x is between A and B, so means between in here or in here. So or 0 less than or equal to x, and x is less than or equal to B. And it's not different. You get equality for the 0 in here or in here. It is not different, and it's no problem. So it's equal to f of x belongs to R such that A less than or equal to x, which is less than or to 0, union of f of x belongs to R such that 0 less than or equal to x, and which is less than or equal to B. And this one gives us when you need to find f of x, so we must square all two inequalities. When we square that one, you know that for any two real numbers, when two real numbers are less than to 0, but when we square it, so we change it these inequalities. So get for this part, f of x belongs to R such that 0 less than to x squared, which is less than to a squared, like that. But for the next part, you don't need the change to the inequality because b is greater than 0. So we just squared this part, like that. F of x belongs to R such that 0 less than or equal to x squared, and which is less than or equal to b squared. So implies that f of h in this case equals to from 0 to a squared union 0 to b squared. And this one is also closed, but we need to union them, and it is equal. F of h equal to two parts, equals to 0 to a2, where in what time? If we have a squared greater to b squared. Since we say that a less than to, in here we say that a less than to b, but you know that a less than to 0, so maybe a squared less than to b squared, and also maybe b squared greater to a squared. So it's equal to 0 to I square if I square greater than B square, and also equals to 0 to B square whenever if B square greater to I square. For this part, sorry, this one is f of h. F of h is closed, and for this part is also f of h is closed. So f of h in this case is closed. The last one, case number C. For the case number 3, if A less than to B and which is also less than to 0, for this one, f of h equals to f of x, f of x belongs to R such that x belongs to A and B, like other parts, and which is equals to f of x belongs to R such that A less than or equal to x, which is less than or equal to B. And to find the f of x, we need the square roots of these parts, these inequalities. But you know that A and B less than or equal to 0, less than to 0. So when we skirt these parts, the inequality changes like that. It's equal to f of x belongs to R such that B square less than to x square, and which is less than to I square, so or equal. So gives us B square to I square, the closed interval B square to I square, which is closed also. So in all cases, we show that the f of h is closed where h is a closed. So we say that f is closed function. F is closed function.